Alright guys, here's video for 2.2, patterns of linear functions. So please, let's pay attention to the patterns. That is what it's all about. If there is a pattern, it is a linear function. We want to know what that pattern is and write it as a rule, okay? So we can predict for other values of x. So I already taught this lesson in class. I just want to go through your homework to make sure you're doing it right. So let's do a few problems. I am going to skip number 1 because it was exactly the same problem I did in class. So you should have in your notes this example right here. If you don't, come and talk to me, or let's take a note from someone else. Let's take a look at these examples right here. Let's go with number 2 and then we'll skip around, do a few more. So it says, for each table, determine whether the relationship is a function. For me to know if a relationship is a function, the x values don't repeat. So let me write it down over here. If it is a function, the x values don't repeat. Okay? So the x values don't repeat. Let's take a look over here. 0, 1, 2, 3. Okay, the x values don't repeat, so it is a function. I know this is a function. Yes, it is a function. So yes, it is a function. And then it says, then represent the relationship using words, an equation, and a graph. All right? So I'm going to go straight to first an equation, then the graph, and then we can see if we can find some little words here down in the bottom. So I know it is a function. For every x value, we have a y value. Let's look at the pattern of this. And we need to look at the pattern for the x values and for the y values. So it looks like from a 2, for me to get from a 2 to a 3, we are adding 1. From a 3 to a 4, we're also adding 1. From 4 to a 5, we're also adding a 1. So we're just increasing on the y values one by one. And on the x values, from 0 to a 1, I'm also adding a 1. From 1 to a 2, and from 2 to a 3, we're also adding a 1. So you see that it has a pattern on the x values and it has a pattern on the y values. And with that pattern, we can continue the pattern forever. So it does have a pattern. Also, we see that when x equals 0, right here, we can create a little function right here. Let me put my x-axis right here. That was a bad line right there. But that's my x-axis, and let me do my y-axis right here. Okay, this is my y-axis. It looks like right here at x equals 0, I'm going to be putting a dot on 1, 2 right here. So that is this order pair 0, 2. And then at 1, x equals 1, I'm going to go up to a 3. 1, 2, 3. There we go. And then at a 2, x equals 2 is right here. I'm going to go up to a 4. 1, 2, 3, 4. And then at x equals 3, right here, 1, 2, 3, I'm going to go up to a 5. So 4, 5. There we go. So it does look like it's going to form a line. If I connect all these dots and I continue forever, I'm going to put an arrow at the end of my line here to indicate that this goes forever. I do have a nice linear function. We know it's a function, we know it's forming a line, so it's a linear function. It does have a pattern. They want us to graph it, which I just did, and they want us to write an equation. It looks like for every x value you give me, I am multiplying by a 2, because if you give me a 0, I'm multiplying that x value times a 1, because that is the value right here, and I'm adding a 2. So it looks like the pattern comes from here. So we write y equals, this value right here is what we multiply the x value. So 1 times x, right there. But my initial amount is a 2. When I had a 0 for x, I also got a 2 for y. So I add a 2 to the back. A positive 2 because this is a positive 2. Okay? So that is our rule for this. So it looks like if you give me a 0, let's double check if our rule is correct. When you give me a 0, I plug it in here. 0 for x is 0, plus a 2, I get y equals 2. So that does work. What happens if you give me a 1 for x? Let's just check it here on the side that our rule works. Y equals, if you give me a 1 for x, 1, plus a 2 for my rule over here, the y value will be a 3. Is that correct? For x equals 1, we do get a 3. So you're checking that your pattern here, your graph does work for your graph and your rule works. So yes, it does. So in words, you would write the y values, you can get the y values equals, you can say 1 times, right? You multiply the x value by 1, and then you add a 2. Okay? So that is the rule. The relationship is every time you give me an x value, I'm going to multiply by 1 and add 2 to it. So if you give me a 4, I'm going to multiply by 1 and I'm going to add 2 to it. So 1 times 4 is 4, plus 2 is 6. So at 4, I would go up to a 6, and yes, that would be part of my line. If you give me a 5, I would multiply the x value by 1. 5 times 1 is 5. And then I would add 2, which gives me a 7. So yes, it does work. Okay? So that is how you represent it. You find the pattern, you see that it is a function, you graph it, you find the rule, and you write the rule in words. So anybody can give me any x value, I will follow your directions here. All right, let's do one more. Let's go here to the back. Let's do number 5 just to see what happens. Okay, so let's take a look at the x values. 0, 1, 2, 3. It is a function. It says for each table, identify the dependent variable, the independent variable. So let me start right here. Dependent and independent. If you look at your notes from previous lessons, the dependent variable is the y value. The independent variable is your x value. And it looks like in the x value here we have an n, and our y value here we have the m. So the m value and the n value. The m value depends on what we're going to do to the n value. Okay, so I'm going to do something to the n, some rule, some operation, and then I'm going to get the m value. All right, let's take a look. It says describe the relationship in words, in an equation, in a graph. I like to leave the words for last. First, I like to look for a pattern and come up with an equation, or first my graph and then the equation. I really like to work this set of things here backwards. If I have an order pairs, I'm going to do the graph first, and then I can come up with the equation, and then I can explain in words. So why don't we do the graph first? I have 0 for x, 1 for y, but I'm going to name it n and m, because that's what we have it now. So 0 for n, m gives me 1 right there. If I'm at 1 here at n, -2, so I have to drop 1, 2 right here. And then at 2, we're going to drop to 5. 2, 3, 4, 5. There we go. And then at 3, right here, 1, 2, 3, I'm going to drop down to a -8. So down to a 5, 6, 7, 8. There we go. If I draw a line through it, let me see if I can do that with this little card I have here. If I draw a line through it, so I can connect all my dots. There's my line. So it looks like for every x value you give me, so you gave me a 0, then I am going up. You gave me a 1, I'm going down 2. So let's see if we can find a pattern from the table. It's kind of difficult to see it here. It looks like we're dropping 3 units. I don't know. Let's take a look at it here. Looks like from a +1, for me to get to a -2, I would have to subtract from a 1. What do I have to add to a 1 to get a -2? It would have to be subtract 3. How do I go from a -2 to a -5? I would have to add a certain value, So I could add a -3. So subtract 3 and it works. And then from -5 to a -8, it looks like I'm also going to have to subtract a 3. So it worked every single time here. And it looks like here I'm just growing by 1. From 0 to 1, 1 to 2, and 2 to 3. I'm just adding 1, and adding 1. So there is a nice pattern on both sides, and we use that for our rule. So I know that y equals, there's also always a number multiplying x, and then we add something to the back. That is the pattern that we discovered in class. This value over here is what we multiply the x. So -3 over this +1 here. So you can put the +1 there. And then in the back is what happens when x equals 0. So at x equals 0, we get a +1. At x equals 0, in this case is n. When n is 0, we get a +1. So there's +1. I shouldn't have used y and x. Is such a bad habit. Let's replace it with our m equals -3 divided by a +1 is just a -3 times the n, and then you add the 1 in the back. So there we go. There is our rule for this function. Every time you give me an n value, I'm going to multiply by a -3, and then I'm going to add a 1. Okay, so that is how you get your pattern for your functions. So if you give me a +1, if I plug in a +1 in here, +1 times a -3 is -3, and when you add a 1, you get -2. So there we go. If I give you a 0 for x, right here, I'm sorry, for n, if I give you a 0, -3 times 0 is 0, and then when you add a 1, you get that point right there. So it does work. It's good to check every single one of them to make sure that it works. So there is our rule. In words, I'm going to let you write it right here in words, exactly what you're doing to the n value. For every n value, so for every n value, we will multiply by a -3 and then add a 1. So I'm going to let you finish that sentence, because that is exactly how you explain what's happening here. You can say m equals -3 times the n value plus 1, or you can say in your own words exactly what's happening over here for the function rule. That's the relationship between n and m is going to depend on n. Whatever we do to n, that's how we're going to get m. That's why the m is a depending variable on the n value. Okay? So you'll be able to do it. I'm sorry I start with x and y's and then I switch to m and n. I'm just so used to using x and y's. Okay, so hopefully these 2 examples of finding the pattern on the left and on the right will help you. Let's see if we can do one more. Let's do number 3 here. Let's go back to the front and let's do number 3. Just so I make sure that you have at least 3 examples. All right, so let's take a look at what's happening here. From 5 to get to a 7, you add a 2. From 7 to get to a 9, you also add a 2. And from 9 to get to 11, you also add a 2. And over here on the right, for the x values, from 0 to 1, you add a 1. To get a 2, you add a 1. To get a 3, you add a 1. So on this side, we're just adding a 1. Eventually, we're going to have a different pattern on the x values as well. But for now, let's keep it simple. So you have 2 on the, you're adding a 2 on to the y values, but you're only adding a 1 to the x values. So we can go ahead and create a rule for it. And remember, the y value equals, depends on the x value. So this number over here that we found out, 2 divided by this number on the pattern on the y values divided by the pattern on the x values is what we multiply our x value by. Okay? And then we look at what happens when you give me a 0. Here's my value right here, my graph. Here's the x-axis and here's the y-axis. So what happens when you give me a 0 for x? I need to go to a 5 for y. So 0, 1, 2, 3, 4, 5 right here. So when you give me a 0 for x, 2 times 0 is 0, but I'm going to get a positive 5. So that is the value that goes back here. Okay? So if you give me a 1, let's see, give me a 1, let's plug it in here. 2 times 1 is 2, plus 5 gives me 7. That does work. If you give me a 2, a 7 would be higher here, and it would be higher. My graph is going off the grid here, but that's what our function would look like. So if you give me a 2, let's check to see that our rule does match our table and it does match our graph. If you give me a 2, I plug it in here. 2 times 2 is 4, plus 5 is 9, and there it is. You got your 9 for y. So it does work. And you'll see that will work for a 3. So our rule is y equals 2, we don't need to divide by 1, times x plus 5. Okay? We do this division here, the pattern on the right divided by the pattern on the left, the y pattern divided by the x pattern, because sometimes it needs to be reduced. We saw an example in class where it was $40 for 2 hours, and we reduced it to $20 an hour. It was something like that. So we need to always divide the pattern that happens on the y values divided by the pattern that happens on the x values. Okay? And that is 2 of our, already did 3 of our problems on your homework. You should be able to finish with the words explanation for 2.2. Okay? So good luck on this homework.